What's up, everybody? If you've been following the Horsepower Monster for any length of time, you've probably seen some of our videos in conjunction with Newcomer Racing. That's engine builder Keith Newcomer right there, and he's been pushing the limits with straight six Jeep motors and also the AMCs and stuff like that. The latest build he's got is really cool. Thought you'd want to see. He is trying to see how far he can take this 60s technology with modern engine controls like a Holley Dominator. He's also fabricated a way to get a racing style crank trigger ignition on here, fabricated his own cam sensor. As you can see, we've got individual coil packs. We're going to show you how he made it all work, and then we're going to bust it off on the dyno to see if it actually makes some power. Hang on, this is going to be fun. We've already done a really cool video with Keith Newcomer building a budget Jeep stroker engine with mostly stock parts. That boosted the stock 190 horsepower engine to just over 300. And there's a link in the description below if you want to check that video out. But now he's trying to blow that number out of the water and make the most naturally aspirated power possible for these engines, burning pump gas and with the same rock solid reliability these Jeep straight sixes are famous for. So that means some serious port work. Previous testing has shown the Edelbrock stock aluminum cylinder head for these engines right out of the box is about as good as a fully ported stock cylinder head. So, in order to get maximum performance, Newcomer has spent about 16 hours porting this new Edelbrock cylinder head. Take, for example, the combustion chambers. The shape is mostly the same. After all, the Edelbrock head is a good modern design with a heart-shaped chamber, but Newcomer knows he's going to be working with a larger cylinder bore, so he was able to lay back the walls of the combustion chambers to help move more air out from around the valves. That also opened up the combustion chambers from 55cc stock on the Edelbrocks to just about 60, but that can be made up with the pistons. Now here's a look at the ports. Newcomer says the trick with these heads when it comes to increasing flow is to raise the roofs of the ports. He doesn't really bother with the floors because so little air flows across the bottom of the ports. He's also widened both the intakes and the exhaust as much as the castings will allow and equalized the port dimensions in terms of both height and width as much as possible from port entry all the way to the valve seat. That also requires a good bit of work around the valve guide boss. Also, to help move more air, the valve sizes have been increased. Newcomer is using LS-based Ferrea hollow stem valves with extra long stems to allow an increase in valve lift from the cam. The intakes have been up from 1 inch 910 thousandths to 2 inches 80 thousandths, while the usual 1.5 inch exhausts are now a full 100 thousandths larger at 1 inch 600. So how much does the port work improve flow? Well, Keith is keeping the flow bench numbers to himself, but he does say it's significant. Anyhow, I put the cart before the horse a little bit with the gorgeous port work on those cylinder heads. Before we can put them on anything, we've got to get the bottom end built. So let's get to that. The block is an OEM 4-liter cast iron unit from a 99 through 04 Jeep Grand Cherokee. Newcomer says these blocks usually have cylinder walls that are just a bit thicker. It's also one of the NVH blocks that are used in later model Jeeps. NVH stands for noise, vibration, and harshness, but it's important to us because these blocks have thicker webbing around the crank bores and include a stamped main girdle, both of which should help overall strength. While the block comes from more modern Jeeps, the crank is definitely old school. This is a fully counterweighted crank out of a pre-1981 Jeep. It's also a crank out of a larger 4.2 liter engine with a stroke of 3.895 inches. That's 481 thousandths longer than the crank from the 4.0 engine the rest of the build is based around. Once the king bearings are in place and the bearing clearance is confirmed, the crank is lowered into the bearing saddles and the cast main cap secured by torquing the main bolts to 100 foot-pounds. Notice the main bolts have studs extending from them. These are for the main girdle we'll be adding later. While the main and rod bearings are from King, the cam bearings are from ACL. Newcomer works with Bullet racing cams for his bump sticks. This one is a mechanical flat tappet that's pretty aggressive for a straight 6. It has 518 thousandths net lift at the intake valves and 527 at the exhaust. The duration is 226 and 232 at 50 thousandths tappet lift on a 112 degree center line. Honestly, one of the biggest hurdles when it comes to building Jeep or AMC straight 6 performance is a lack of aftermarket support. There just aren't the same options out there that you can find for Chevy and Ford V8s. The connecting rods are forged units from Eagle. Unfortunately, they only come with a press-fit pin bore, so Newcomer modifies them himself with bronze bushings so they will accept floating wrist pins which don't rob power like press-fit pins. The big ends of the rods are also upgraded with ARP 2000 bolts, and like we already mentioned, they're outfitted with King rod bearings. These rods are also slightly longer than stock to improve the rod stroke ratio. Here's a stock rod on the left and one of the 6-inch 125 Eagles on the right. Mounted up to the connecting rods are a set of custom slugs from JE Pistons. These are 30 over, so the bore is now 3.905. Combined with the longer 3.895 inch stroke, that makes total displacement 4.58 liters or 280 cubic inches. The pistons are flat tops with valve pockets just large enough to clear the valves. Wire locks keep the wrist pins in place. And the rings are a lightweight, low friction set sized at 1.5 millimeters for the top and second ring and 3 millimeters for the oil ring. Notice how easy it is to slide the pistons into the bores with the low drag oil rings. Now we don't really care how easy it makes the engine to assemble, but that does translate to more horsepower when the engine is running. Newcomer just snugs up the caps and rod bolts, and then once all the pistons and rods are in the block, he flips the engine over so Devin Rao can torque up the ARP 2000 bolts to 45 foot-pounds. Like the camshaft, the solid flat tappet lifters are from Bullet Racing cams. It can be really tough on a flat tappet valve train running an aggressive cam lobe and lots of RPMs. So these lifters have a very tiny hole cut into the face of the lifter that injects pressurized oil into the area between the cam lobe and lifter face. This oiling hole significantly helps improve durability. Newcomer installs the upgraded double roll timing chain and degrees in the cam to make sure the valve train is set up exactly where it should be. And now we've finally made it back around to the ported Edelbrock cylinder head we started out discussing. I just can't get enough of those big old ports, but the real skill when it comes to hand porting is making all 6 intake ports and all 6 exhausts exactly the same. We haven't discussed the valve springs yet. These are actually a set of Brian Tooley Racing springs for an LS engine modified to work for this application. They're a double nested spring setup, but Newcomer reduced the overall spring pressure by using just the outer spring. Lots of installed height is needed because the total valve lift will be just a bit over ½ an inch. Using just the outers, there's approximately 100 pounds of pressure on the seat and 280 over the nose. The extra long valve stems are necessary to get the tall installed height because you can't cut the spring seat on these heads deep enough to keep from getting in the coil bind. Titanium retainers help keep the overall valve train weight down. The head bolts are run down to 80 foot-pounds in 3 stages. The push rods are super stiff 3/8 inch diameter, 80 thousandths wall hardened steel units that are 9 inches 300 thousandths long. And you should probably be able to tell by now that Newcomer plans to make this straight 6 scream on the dyno, way up in the RPM range where most engines like this would have long ago given up the ghost. The rocker arms for this build are also pretty trick for a Jeep. They're 1.7 to 1 ratio aluminum rocker arms from Scorpion Racing. These are full roller rockers with a 1.7 ratio, a bit more aggressive than the stock 1.6. Here's a shot of a stock replacement set of stamped steel rockers so you can see the difference. Besides adding more lift and duration with a higher rocker ratio, the fully roller Scorpion rockers should work more efficiently than the stock units. Plus, the beefy aluminum rocker bodies are much more resistant to flex, which can ruin valve timing in the running engine. Newcomer did find that he had to grind a bit of material off the back corner of the two rockers on the very ends to clear the valve cover, but that wasn't a big deal. Once everything is in place, they're lashed to 12 thousandths of an inch for the intakes and 10 thousandths for the exhaust cold. The target hot lash will be 18 thousandths all around. The oil pump is a standard volume melling unit, and the oil pickup is for the stock pan, which we'll be using. But before the pan goes down, Newcomer first installed the stamped steel main girdle. The girdle bolts down using the studs that extend from the main bolts, but because this is a stroker build, you'll notice that the spacers have to be used to create just enough clearance for the connecting rods as they swing by. Once Newcomer confirms that we aren't going to be crashing the rods into anything, he torques the main girdle down tight and then adds the one-piece oil pan gasket. The one-piece gaskets are a huge improvement over the old four-piece pan gaskets, but they can still potentially leak in the corners. So a little oil-resistant silicone there helps assure that this engine won't be drooling on the driveway once it's in its permanent home in a Jeep. With the oil pan in place, the engine is rotated back to right side up and break-in oil is poured in through the drain holes in the cylinder head. Newcomer spins up the oil pump while Raul rotates the crank and valve train until they can see that oil has moved up through each rocker arm. Now we're ready to seal up the top of the engine, but the standard valve cover can have trouble fitting with the taller valve train, so Newcomer has his own valve cover spacers machined to his specs. After the first gasket goes down, this pin helps locate the second gasket so it can't move. Then the 3/8 inch thick CNC cut aluminum spacer goes down with another gasket on top. This is a stock cast valve cover that's been machined and touched up a bit, and it now has plenty of clearance for the aftermarket valve train setup. Now we're getting to the part of the build where you've never seen this stuff before on a Jeep innovation starts. Newcomer wanted fully computer controlled EFI, and we're not talking about the stock hard to work with stuff here. We're talking about fully modern aftermarket EFI systems that are unlocking so much power these days on this engine. But like we've already mentioned, the Jeep and AMC Straight 6 lacks a dedicated performance aftermarket like many V8 engines. So we asked Newcomer to explain how he made it all work.
All right, so one of the challenges we had was trying to run a motor like this with a bunch of options was the fuel injection. We could have possibly taken one from an OBD2, stripped the harness, and made it work that way. We've done that before, but we decided to go all aftermarket. We can control everything. So we worked with Holley with their HP system, and one of the challenges a lot of guys will see is there's not a good trigger for the crank. So we came up with this. We got the weights, everything in it. We got the pickup, a mount, and we'll just adjust it to get our air gap where we want it. And so one of the stumbling blocks in this system is a cam sync. They're not available, you can't get them. So we came up with this one, and it'll support pretty much any aftermarket system. This is a stock one, Hall effect sensor. It simply, turns, goes through the window. But their system, most systems don't support that. They want a cam sync. So we came up with this. It's actually got the magnetic pickup inside. It's all machined. And this is just like a stock one. So what you'll do is put it, if I can get on here, it'll fit just like a stock one. You'll take this in until it bottoms out. Once this is tight, and then it'll bottom out. It's bottomed out, and then you back it out 50 to 80 thousandths. You set it, lock it down, and there would be your air gap, and it would get the proper signal to support that kind of system.
The crank trigger also required a bit of work. A crank trigger replaces the distributor. It's much more accurate because the greater diameter of the trigger wheel compared to a distributor reluctor provides much greater resolution when it comes to cylinder timing. Newcomer started with a generic no-name trigger wheel and retrofitted it to work on the Jeep engine. But the good news is Newcomer planned to work with either a Holley HP or a Dominator ECU, and either works practically with any brand crank trigger and pickup and controls everything without a hitch. The ignition is also converted to a modern individual coil setup using Holley smart coils because they provide a stronger, more consistent spark than the single coil traditionally used with this engine. To make it all work, Newcomer fabricated a coil bracket that mounts tight to the block so everything still fits in the engine bay. You will notice that the main bracket holds 5 coils, while a 6th sits slightly below the rest in order to get everything to fit clean and tidy. The reworked cam position sensor fits right where the distributor would. While the crank trigger tells the ECU the location of the pistons, the cam sensor helps the ECU know when each cylinder is on its compression stroke and ready for a spark. This obviously is the first and only one in existence, and it required a ton of hours to science out and machine up. But Newcomer says he's looking at ways to manufacture them more economically. One of the quirks of the Jeep head is that the intake and the exhaust are on the same side. Jeep uses bolts and thick washers that catch the flanges of both the intake and the exhaust to seal them up against the head. This can create an issue if you're using an aftermarket intake and exhaust like we are, because the flanges are likely to vary from stock. The stock washers are often just too small, like you see here, and often won't fully seat against the flange, leaving you to hope for the best. After dealing with this issue one too many times, Newcomer has developed his own steel washers laser cut from thick steel plate. These come in 2 different shapes, and they're thick enough that they shouldn't bend no matter how much you crank down on them. Here, you can see how the stock washer doesn't make enough contact with the flange on an aftermarket intake manifold, and now how Newcomer's laser cut washers fix the problem. But that was just for mock-up. By the time we got to the dyno, Newcomer had 2 custom fabbed intake manifolds ready. One was a traditional style intake with a top mount throttle body. The second intake, I'm calling it the Cannon, maybe that'll catch on, is a front mount with a huge plenum and shorter but equal length runners. It's going to go onto a later big turbo build and is all cut from billet aluminum, but we wanted to see how it compares in a naturally aspirated application. Since this is an R&D piece, he didn't have a jig, so he carefully welded little bits at a time, moving around the intake to minimize heat warp. So let's take this bad boy to the dyno. We're at the dynos of Automotive Specialists in Concord, North Carolina. You may be familiar with that name because we've also done several engine builds with the guys at Automotive Specialists. Besides using their dyno, Jeff Dorton is also helping with tuning the EFI system. First up, we're testing with Newcomer's custom fabbed intake in the traditional layout. That's a 93mm throttle body mounted on top of the intake. There's also a set of 48cc injectors from Excel installed on the runners to provide fuel. Everything on the engine plugged right in with a Holley wiring harness, and as we already mentioned, the engine controls were handled with a Holley Dominator ECU. The programming allows Dorton to simply upload the engine parameters on a laptop, and a baseline fuel map is built automatically. From there, Dorton can adjust the fuel and timing curves from the laptop as he sees fit. One note, you will notice the exhaust header change. The other header is a custom-built stainless steel piece that Newcomer fabbed for a no-holds-barred turbo build he has coming up. And believe me, we're going to cover that one too. After initially setting everything up on the dyno, Newcomer decided to make an update to the prototype crank trigger assembly. By the time we got back on the dyno, he was already mocking up the turbo plumbing for his turbo project, so we switched over to this header for the dyno testing. Anyhow, enough talking. Let's get to it. thorough break-in, remember these are flat tappet lifters, and several different runs to see where the engine likes spark timing and fuel, Newcomer pulled this 280 cubic inch 6 all the way to 6,200 RPM, which is screaming for an engine like this. It made peaks of 367.4 foot-pounds of torque and 395 horsepower. That's 2 times the 190 horsepower the original engine was rated for. But for you big tire guys, it's the torque line that's going to look a lot like Christmas. The pull starts at 298 foot-pounds of torque, ends at 334, and never gets lower in between. What's cool is that Dorton was able to take advantage of the Dominator ECU to tune the engine to maximize power, but we should still have great low RPM manners on the street or trail, even with the giant throttle body.
This one, this is the first time for me, you know, on Holly HP. Jeff Dorton helped me a lot on it, and you know, I got to give him all the credit. But I will say it's pretty cool. You know, I'm not going to do a jet change. Hold on a minute, boom, boom, boom. It's a live change, make another pull. And it's just one after another. You can change everything. You can look at everything. It's a lot of work to get this done, but in the end, it runs awesome. It's hard to beat.
So that already makes this day a success, but Newcomer also wanted to test the cannon. The idea here is to see how the equal length runners and large plenum affect the power curve. We're using the same size throttle body, injectors, and fuel log. By the way, in case you're wondering, those 2 large braided lines running up from the valve cover are just breathers. After a few tuning runs, we were able to find the best fuel match for the cannon. It made better peak torque, 374.2 to 367.4, which is an improvement of 6.8 foot-pounds. But we lost 4 peak horsepower. Overall, however, the Jeep Straight 6 did seem to like the cannon better, with improved averages of both torque and horsepower across the range. But I'm sure you probably noticed the dip in power starting around 5,200 RPM with both pulls. I suspect that this is probably the valve springs hitting a harmonic range that affected valve control and consequently hurt power. A double nested spring is normally more resistant to harmonics, and using just the outers may have been an issue. Anyhow, fixing the dip will likely be as simple as a valve spring swap. Unfortunately, we didn't have any on hand on the dyno session, so we can't show it to you. Overall, outfitting Jeep's iconic Straight 6 with modern engine controls, a crank trigger ignition, and individual coil packs was a bit of a project, but the results were better than even Newcomer had hoped. It made great power all the way across the RPM range, and once the engine is in a vehicle, it should be as easy to start and reliable for daily driving as any new vehicle you can drive off the lot. We call that a win. Hey, thanks for watching. Please like and subscribe, and we'll see you next time for another great engine build.